Hello PreCalculus students. Welcome to a video on part 2 of section 5.1. Remember, section 5.1 is on trig identities, and here we're verifying. And remember, an identity is not an equation. It's basically when two expressions equal each other all the time for all x values, and we just want to just prove that it holds true. So you need to do some sort of manipulation to one of the sides so that it equals the other side. Now remember, we want to work on the more complicated side if you can. Do consider some sort of substitution, and of course some algebra. So obviously the left side is more complicated here, and I see an opportunity to combine two fractions, so I'm going to figure out what the LCD is, the least common denominator. And basically just the product of our two denominators we see right now, 1 plus sine x and cos x. So what we're going to do is we got cos x over 1 plus sine x plus 1 plus sine x over cos x equals 2 secant x. So obviously the second fractionary needs 1 plus sine x both top and bottom. And here we need cos x. So if I work the second, cosine squared, and I got to FOIL, obviously, all this jazz over here. 1 plus 2 sine x plus sine squared x. And of course the bottom is just this. Now I'm going to caution you, don't distribute the cosine x and the 1 plus sine x for the denominator here, because we're going to want to get something to cancel, because the fact that I see a secant over here, remember that's 1 over cosine x, so I probably am going to want to get rid of the 1 plus sine x in the bottom of the left fraction, this really big fraction. Now, fortunately, I see this opportunity where I can combine sine squared and cosine squared. So together, that will become 1, and you still got the 1 plus 2 sine x. And of course, the bottom is all this. Now, 1 plus 1 is 2, duh, right? And you get factor out 2 from the top. It's kind of like magic. The 1 plus sine x is now will cancel because they're both being multiplied to other expressions. And you get 2 over cos x, which is really just 2 secant x. And it's verified. This is definitely a more lengthy one. And we'll practice in class, but that's kind of how it's done. You want to work on the more complicated side, use a little algebra if you can. Do consider some substitution, which we did do with cosine squared plus sine squared being 1. And then just continue with some more algebra, like combining like terms, factoring, and simplifying. And then, of course, 2 cos x. 2 over cos x is 2 secant x. Now, in this case, it's not quite clear which side is more complicated. You could cross multiply, but I'm going to advise to not cross multiply. Reason being is that, well, it's kind of like cheating, but also you could somehow make a mistake when you start moving things from left to right, and then all of a sudden you're spinning your wheels. So I'm going to show you another technique. Now you can work on either side in this case because they both look equally complex. So here's the little trick I'm going to do. I'm going to work on the left side. You could work on the right side also. But I'm going to multiply top and bottom by 1 minus cos x. The reason why is that there's 1 minus cos x on the other side, so I need to make the left side look like the right side. And if I do that, and hopefully you recognize, sine squared x plus cosine squared x equals 1. So sine squared x, of course, is 1 minus cosine squared x. So I could just replace all this right here with just sine squared x. Now I got sine x over sine squared x. When you have like x over x squared, we know it's 1 over x. So it's kind of the same thing. And now you got them verified. 1 minus cos x over sine x equals that, and it checks off. Okay, last one. Now, we talked about on the first page of these notes, sine negative x is negative sine x. It's an odd function. And obviously I'm going to work on the left side because it's more complex. So it becomes obviously a plus. Now, what I probably will wind up doing here is converting tangent to sine over cosine to make that sine x over 1. Of course, the bottom is still 1 plus cos x. So we talked about this before. Anything that's not sine or cosine, convert it. And of course, I see an opportunity to combine these fractions now. Multiply top and bottom by cos x. So you have sine x plus sine x times cosine x all over cosine x. And the bottom is still 1 plus cos x, but I'll make it 1 plus cos x over 1. So now we have two fractions being divided. The one I'm highlighting in yellow, and the one I'm highlighting in, say, turquoise. When you divide fractions, you always flip the fraction that's on the bottom in terms of multiplication. Simultaneously, I'm going to factor out sine x from the numerator of the top fraction. And those cancel. So now I get sine x over cos x, of course equaling tan x. That's what's on the right side. And of course, sine x over cos x is tan x from our sheet in the front. And now it's verified. So we'll discuss this in class again, but I want to make sure I modeled the process. Go ahead and try the homework problems that are related to examples 5, 6, and 7. And we will meet again soon. Goodbye.